Okay, today we're going to continue on with our triangle similarity postulates. Today we're going to talk about side, 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 and side, angle, side similarity. We've learned that to prove two triangles are congruent, we have to state that all the corresponding angles are congruent and the corresponding sides are proportional. Then we learned that we'll be faced with situations in which we will not have enough information. And because of this, there are similarity postulates that can help. And one we learned before was angle-angle similarity, and today we're going to learn two new ones. The first one's going to be side-side-side similarity. It states that two triangles are similar if all three of their corresponding sides are proportional. So we don't need to check their angles. We just need to make sure that all three of their corresponding sides are proportional. So let's try out example number one. Let's see if LDY is similar to BUG. So we have 12 over 8, and we want to know, is that equal to 9 over 6, and we want to know if those two are also equal to 6 over 4. Okay, so it's a little hard to look at right now, so what we're going to do is we're going to go ahead and we're going to reduce the fractions. So 12 over 8 reduces to 3 over 2, and the next fraction here is going to reduce to 3 over 2, and this last fraction is divisible by 2 on the top and the bottom, so it also reduces to 3 over 2. So here we have all three sides being proportional. So you say by side, side, side similarity, triangle LDY is similar to triangle BUG. Okay? So you're just checking to see if all three sides are proportional. I'm going to have you all do number 2 for class, so the next time you come into class, make sure you have number 2 all done, and then we're going to talk about it when you get there. All right, the second one that we're going to learn today is side, angle, side similarity. So what you have to do is you have to have two corresponding sides be proportional to each other, and then the included angle has to be congruent. And included angle, I mean the elbow, and here's what I mean. Like if we draw a triangle like this, if we have this side and we have this side proportional, this is the elbow. That's the angle I'm talking about. That's an included angle, okay? So let's move down here and look at these problems. So on number 3, we have, it looks like they're trying to spell giraffe. And we see that we have a side, and the elbow. A side, and the elbow. So that's the included angle. So we're looking for side, angle, side. You want to make sure that your sides are proportional. So you want to ask yourself, is 14 over 7 equal to 16 over 8? Now when we reduce 14 over 7, we have 2 over 1, and when we reduce 16 over 8, we have 2 over 1. So this works. Furthermore, angle I and angle E are congruent. So we have two sets of sides. We have two sides that are corresponding and they are proportional, and we have an included angle that is congruent. So we can say by side, angle, side similarity, triangle GIR is similar to triangle AEF. Like that. For class, go ahead and try number 4 out, see what you get. So have number 4 completely done when you come to class so we can discuss it. And once you got that, go ahead and flip over your paper to the back side. We're going to keep going here. It says, remember with overlapping triangles that we need to add the numbers together to get the lengths of the sides of the big triangle. So here we have this triangle, okay? And there's a small triangle inside. So big triangle, little triangle. And it's hard to tell the lengths of the larger triangle unless you actually draw this out. So I always recommend go ahead and draw the small triangle and then draw your big triangle. So let's think about the lengths of this side. 3 and 4. So that whole length, we would add those together and we would get 7. And the length on this side, 8 and 6. And when we add both of those together, we get 14. So if they want little triangle over big triangle, we have 4 over 7 equals 8 over 14. Now it doesn't look like those are equal, but you would have to go ahead and reduce your 8 over 14. And 8 over 14 does reduce to 4 over 7. Now it's saying these triangles are similar by what? Okay, so let's think about what we've learned. We've learned angle-angle similarity, side-angle-side similarity, and side-side-side similarity. And all I'm seeing here, two sides that are proportional. None of these are just side-side, right? So it's either side-angle-side or side-side-side. But we don't know this side right here at all, but we do know something about an angle, and this is what really trips a lot of students up. See this angle up here at the top? This angle right here? That angle is the same in that triangle as it is in this triangle. It's in the little triangle and it's in the big triangle. So if you look at this now, you can see it's side, angle, side. Okay, so watch out, that little triangle, or that little angle always gets people in my class. All right, now that we have that, let's keep going. We're gonna solve for x and do some algebra on the next problem. So on number 5 and 6, it says they're already similar, so we can go ahead and break up our triangle. I actually think I want you guys to do number 5 for class, and let's go ahead and do number 6 together. So on number 6, we have 12 and 8 for our little triangle. And now let's talk about our large triangle. So I know on the bottom we have 10 right here. But what about this side right here? It's an x and a 12. Let's go back up here really quickly. This side right here, what do we do with these two numbers? We added them to get 7. So if we move down here, we would still add these. Now, for some weird reason, I'll tell students, or ask students, what's x plus 12? And a lot of them will tell me it's 12x. Think about what you're saying. X plus 12 is not x times 12, right? So make sure it's x plus 12 that you write down on your triangle. Then you want to set up your proportions. So 12 over x plus 12 equals 8 over 10. Then you want to cross multiply. So 12 times 10 equals 8 times x plus 12. Once you get to this point, you have parentheses, so you want to distribute that in, and let's go ahead and clean this up. 120 equals 8x plus, and if you work this out in the calculator, it's 96. We want to eventually get x alone. So what we have to do to both sides here is subtract 96, and when we do that, we have 24 equals 8x. 8 times x. The inverse of 8 times x is to divide both sides by 8, and we have 3 equals x, and we're all done. So draw your two triangles out, then set up your proportions and solve. Go ahead and try that on number 5 and bring that with you to class the next time I see you. Okay, let's move down to the bottom here. Determine if the two triangles are similar. If they are, write a similarity statement and find the scale factor from B to A. So let's look at this right here, and let's go ahead and look at what they've given us. Look at this picture. We know all three sides. I don't see any information whatsoever about the angles. So if we have angle-angle similarity, side-side-side similarity, and side-angle-side similarity to choose from, and we know three sides, that means we want to look for side-side-side similarity. So we need to check to see if all three of these sides are proportional to each other. 8 over 6, is that equal to 12 over 4? And is that equal to 9 over 3? Go ahead and reduce your fractions. 18 over 6 reduces to 3 over 1. 12 over 4 reduces to 3 over 1. And 9 over 3 reduces to 3 over 1. So all three of these sides are proportional to each other. So we can say, by side-side-side similarity, triangle DMR is similar to triangle STK. Okay? Now this last one right here, number 8, what I want you to do is cross that one out. That problem is actually not a good problem, so we don't need to talk about that one. There's a little mistake on it, so you can cross it out. You don't have to do it. And this is the end of the note. So when you come into class, make sure that you have those couple of problems I asked you to do completed, and we will go over them when I see you again. Until next time.